Hello and welcome to this session on effective questioning in maths for vocational contexts. I'm Elena Bennett and I work in the provider development team at NCFE. This is a recorded version of the live taster event that took place on the 18th of December 2024. This short taster session is just the beginning of the journey. On the 9th of April 2025, we'll be offering a more in-depth paid training event where we'll dive deeper into how to address common challenges, use targeted questioning techniques to engage learners, and provide practical strategies to enhance your teaching practice. So this session will dip into a few ideas. The longer session in April will delve more deeply into the following areas: identifying common challenges with mathematical understanding, considering how questioning techniques can deepen mathematical understanding, and discussing strategies for developing mathematics in vocational contexts. So before we start, we're going to have a quick think about why questioning is so important. So I've got a little quiz for you to do. There's 3 questions, and I want you to have a go and see what you think. So on average, how many questions do teachers ask per day? So do you think that's around 50, around 200 or 400? Question 2, approximately what fraction of teaching time accounts for questioning? Is that around a tenth, a third or a half? And question 3, on average, how long do teachers wait for a response to a question? So do you think that's about around 1 second, around 5 seconds or around 10 seconds? If you want to pause the video here to have a think about those questions, that's fine. If not, I'm going to give you the answers now. So question 1 is actually around 400 questions a day, according to the research. So in the span of a full teaching career, that could be around 2 to 3 million questions. Question 2, it's around 1/3 of the teaching time that is devoted to questioning, which is second only to the amount of time given for explanations. And then question 3, the time, according to research, for a response to a question is actually just under a second, about 0.9 seconds, before a teacher actually takes a response from a student or answers the question themselves or just moves on. So I think you can see from this that actually questioning is very important in teaching, and being able to do that effectively can really benefit your learners. So before we look at different questioning techniques, we're going to first of all consider some of the common challenges that students encounter with mathematical understanding. So I would like you to pause the video here and just have a few minutes to think about what you think your learners find difficult in maths. So, if you're teaching a vocational concept and it involves some sort of calculations or mathematical thinking, are there some common areas or some common misconceptions that learners encounter? So this slide here is a screenshot of the Padlet, which was completed during the live online taster session. So you can see what participants have suggested in their own context, and where learners are finding maths challenging. So there are a few key themes here, things like understanding what the question means and how to approach a question, how they can apply these skills to everyday life and real world scenarios, and things like understanding the terminology and remembering formulas, and then also with worded problems and problem solving and being able to know how to tackle a question. And somebody suggested reverse calculation, so really having that deeper understanding of a concept to be able to sort of apply it when it doesn't look quite as familiar or straightforward. So some really nice ideas here. So we'll now look at some of the main areas where learners on vocational courses often encounter common maths errors that can impact their learning and their practical application of skills in their fields. So you can see if any of these align with the ideas you came up with on the previous slide. So misinterpreting units and measurements. Many vocational tasks require precise measurements, for example in construction or health or hospitality. Students can often confuse units like, for example, inches versus centimetres, or struggle with conversions like how many grams there are in a kilogram, which leads to incorrect calculations. Errors in ratio and proportion. So again, vocational fields such as culinary arts, engineering and healthcare often require scaling up and down. So misunderstanding ratios, for example, doubling ingredients or adjusting dosage can lead to major calculation errors. Students also need to know that a ratio of 1 to 3 is not the same as a third, for example, like knowing what those numbers in a ratio actually mean. Decimal and fraction confusion. So in sectors like finance or automotive or electronics, students can easily misplace decimal points or improperly convert between fractions and decimals, which affects precision. For example, using 0.05 instead of 0.5 in a formula would significantly change the results, and not understanding how to convert. So thinking things like, for example, a quarter is 0.4 because it has a 4. Difficulty with estimation and rounding. In practical settings, estimation is often useful for quick checks, but students can struggle making reasonable estimates, which can be an issue in trades that rely on quick assessments, such as construction. And also, rounding incorrectly or too early can impact the accuracy of problem solving, particularly in trades requiring precise measurements, such as machining or engineering. Rounding should ideally only occur at the final step to maintain precision. Struggles with time calculations. So students often struggle with reading the time when it's an analog clock, but also converting between times. So for example, not realizing that 0.2 hours is not the same as 20 minutes. They do struggle with converting between these units and working with 24-hour formats. Difficulty with percentages. So, for example, calculating discounts, tax, or other percentage-based values is crucial in areas like retail, finance, and hospitality. They often mix up things like percentage increase or decrease, or miscalculate when applying percentages. Basic arithmetic errors, so just anything to do with addition, subtraction, multiplication or division. These errors often arise if students don't have robust methods, or if they're rushing or don't double check their work. Some common errors are things like multiplying a decimal here, that 0.2 times 0.3 is not 0.6, it's actually 0.06. So being aware again of things like place value. Misunderstanding formula. So many vocational fields do require specific formulas, such as area and perimeter in construction, or formulas in finance or healthcare. Students forget formulas, apply them incorrectly, or mix up variables, leading to incorrect solutions. Failure to read problems carefully. Misunderstanding what a question is asking, especially wordy problems, can often lead to incorrect approaches or answers. This can be problematic in contexts that rely on specific details, like calculating materials needed for a project. The example I've put there is of and off, so the percentage of an amount versus the percentage off an amount. That's a very common area in terms of misreading a question. And then confusion with negative numbers. So this can happen in contexts like accountings or electrical trades. Students often misinterpret negative values, such as failing to apply the negative signs or struggling with calculations like the one given, where they have to add with negative and positive numbers. So understanding some of these common errors should allow vocational tutors to target specific areas, allowing students to build a stronger foundation in the math skills that would be relevant to their field. Right, so now we'll have a look at a couple of different questioning techniques and some teaching strategies that could help to develop and deepen learners' mathematical understanding. So for the purpose of this taster session, we're going to focus on a couple of different strategies, which is firstly open and closed questioning, and the second one is tackling problem-solving questions. We're going to have a little look in more depth at the difference between using open and closed questioning strategies in math teaching and when and how to use each to enhance learning. So closed questions typically have one correct answer, such as what is 5 plus 7 or what is the formula for the area of a rectangle. The benefits for these sort of questions are that they are efficient in checking basic understanding, skills recall and factual knowledge. They can build confidence in foundational concepts, which is critical in maths where skills often build sequentially. Teachers and students both receive instant feedback, making it easier to identify if students are ready to progress onto something more challenging. And closed questions are effective for drill practice and practicing specific skills. So the disadvantages of closed questions are that they encourage rote memorization rather than deep understanding or application. They offer little opportunity for students to explain their reasoning or engage in dialogue. Students may feel restricted by right or wrong answers, reducing creativity, and students may guess or memorize answers without truly understanding the process. So open questions. These sort of questions encourage deep thinking and exploration. Examples given here are things like, how many different ways can you solve 15 plus 25 mentally? If you were designing a rectangular garden with a fixed perimeter of 20 metres, what dimensions could you choose? How would that affect the area? So these questions do develop problem-solving skills and foster a deeper understanding. They encourage students to apply knowledge flexibly and creatively, which is essential for real-world maths application. They prompt students to explain their reasoning and share strategies, enhancing mathematical communication, and they allow for multiple paths to a solution, helping students become more resilient and adaptable learners. Open questions can also connect maths to students' personal experience and interests, making learning more meaningful. There are disadvantages to open questioning in that they can be intimidating for some students who lack confidence or find it difficult to articulate their thinking. Discussions and diverse responses can be time-consuming, therefore limiting time for other tasks. And the open-ended nature may lead to off-topic answers or confusion. For example, a vague question like, "What do you think about this problem?" may result in scattered responses. So assessing the quality of the answers can there be subjective and more complex. It's important to be aware of both of these styles of questions though, because both have their place within maths teaching and learning. So how can you balance both open and closed questioning within your teaching of mathematics? A suggested approach is to start with closed questions to build a strong foundation and then follow that up with open questions that encourage exploration and application of the foundational skills. This combination should support a holistic approach, developing both computational proficiency and conceptual understanding. So there's a little activity for you to try now. If you can look at the 3 closed questions below, can you create an open question for each one relating to your vocational context that would stretch learners' understanding? So I have given an example for each question as a starting point. So if you want to pause the video here and give yourself 5 minutes to come up with 3 open questions relating to those 3 closed questions. So this slide and the following 2 slides are again screenshots from the Padlets from the live online taster session. So this first one looks at the statistics closed question and gives some different examples of how you could expand a closed question related to data handling to really get students to think about, why is a certain average or a range appropriate? What does it tell you about the data, and what would be the impact of that? So some really nice ideas here. And this slide was related to calculating the area of a rectangle. So again, in order to deepen understanding, some people had suggested things like, how do you calculate the area? And also getting students to think about why it would work, not necessarily just rote learning, the fact that it's length times width. And if you extended the area, the room, what would happen to the area? What if the room wasn't a rectangle? What if it was a triangle? So really getting students to think a little bit beyond their comfort zone, or just the confines of the question. And the ideas on this slide relate to the ratio example. So there's again really good ideas here. What would happen if sort of questions. What if you added too much of one of the components? What would happen then? How could you change the ratio to alter the overall colour of the red, green, blue, the top right hand example there. So again, some lovely examples of how you can develop your students' understanding just by altering the framing of a question. Now we're going to have a look at problem solving in real world contexts. This is something that vocational tutors do fairly regularly with learners, but it's also something that learners can find very challenging. So questions like this that require multiple steps and operations, learners often don't know where to start. They struggle to interpret the question and therefore also struggle to identify what maths is required. So to support and individualise these questions, you could offer scaffolding to break the question down into step-by-step chunks. So your task here is to have a read through this question and see if you can break it down into more easily readable step-by-step chunks. So pause the video here. You probably will find that there'll be somewhere between about 5 and 7 steps to this question. So give yourself a few minutes to see if you can work out what would be a logical approach for a learner. Okay, so now we'll have a look at how this question could be broken down. So with a question like this, it might be useful to encourage your learners to sketch the problem. It's quite a visual question, so drawing the actual floor out can give them a useful starting point. They can also imagine how the tiles would fit into the floor itself. Step 2, calculate the area of the kitchen floor. So we know that it's 4 by 5 meters. The tiles will cover the floor, therefore it's going to be an area question, so that would be the next step. The third step, it would be useful to calculate the area of one of the tiles. Now, your learners do need to be really careful here because the units for the tiles are given in centimetres and the kitchen floor is given in metres. And I would encourage learners to look out for this sort of issue in a question and convert those units before they do any more of the solving the problem. It will make it easier to convert them at the beginning rather than the end. Then step 4, you can now work out how many tiles are needed. So if you've got the area of one tile, you can see how many times that fits into the full floor. Step 5, therefore how many packs are needed. It says that there are 10 tiles in a pack, so you can divide your number of tiles by 10 to work out the total cost. So step 6 would be calculating the total cost of the tiles. And finally, the step that learners do often forget is to check their answer against the estimated cost of £300. The question asks, will £300 be enough? The learners must answer yes or no because often they will lose a mark at the end of a question for not answering that part. So, do their working out, work the problem through and then make sure they answer the question at the end. This taster session has considered a range of mathematical questioning techniques and strategies that you could incorporate into your teaching. If you're interested in attending the session in April, we will delve more deeply into a wider range of practical strategies and useful tips. In the meantime, from this session, think about a change you can make to your teaching practice in terms of your use of mathematical questioning strategies. There's some ideas below here if you need a little bit of help. So, for example, planning math-specific questions to promote problem solving, assessing understanding of key concepts, and ensuring all students engage with the topics. Going back to that initial question, allowing thinking time for students to process mathematical problems and consider their approaches before answering. Creating a safe space where learners feel comfortable to test solutions, explain their reasoning, and learn from their mistakes in their calculations or methods. Challenge students further with follow-up questions such as, what would happen if this number changed, or can you explain why that works? and encourage collaboration with strategies such as think, pair, share to help students explain their reasoning, solve problems together and support quieter learners in contributing. Thank you for watching this video. I hope to see you in April to really look in more depth at how effective questioning can improve mathematical understanding. The QR code here will take you to an evaluation form. We really appreciate your thoughts. Thank you again and hope to see you in April.